Well, hello and welcome to the third tutorial on applications of matrices. This time we're going to be looking at our third objective, which is the encoding and decoding of secret messages using matrices. So let's go through our lesson here. Here is our area of a triangle, and here is our collinear points. So here we are on cryptography, and cryptography is the study of codes and code breaking. Code breaking. So if you're interested in cryptography, matrices might be a good thing to go and study. I am going to just choose a random 2 by 2 matrix right here, and I'm going to call this the encoder matrix. In fact, I'll go ahead and call it matrix E for encoder. What we need to do is use that to find our decoder matrix. To find our decoder matrix, we're simply going to take the inverse of this encoder matrix. So since our decoder matrix is an inverse, I'm going to use the symbol for inverse. And I know that this is going to be 1 divided by the determinant times our switch it up matrix. So I need to find the determinant first, and that's going to be doing our little fish thing here. So we've got this diagonal, which is 4 times 0 is 0, minus this diagonal, which is 2 times -5 is -10. 0 minus -10 is +10, so that's the determinant. And then to switch this matrix up, the 4 and the 0 will switch places, and the 2 and the -5 will stay where they are, but they will become the opposites, so a -2 and a +5. This is our decoder matrix, and again, the relationship between these two matrices is that they are inverses. These are inverse matrices. Okay, and these are the matrices that you definitely want to keep secret. If you're trying to encode and decode messages, you do not want to give either of these two matrices out because then somebody's going to be able to break your code. So let's talk about a basic code that we're going to be using. For basic code here, let me choose a good color. Basic code, we would assign each letter to a number. If we want to use a space, we might assign that to a 0, and A, since it's the first letter, would be 1, and B would be the second letter, so 2, and C is 3, and ... M would be equal to 13, ... down to Z, which would be equal to 26. So this will be the basic code that we use, so 0 through 26. If you want to use a period or an exclamation point or even quotation marks, you can assign different numbers to them. But this is just our basic code, and we'll go ahead and use that. So let's figure out how to encode this secret message, which is ADV space ALG. A fascinating secret message to encode. First, what we need to do is assign a number to each of these letters. So since A is the first letter of the alphabet, that's going to be a 1. D is the fourth letter, so it's a 4. V is the 22nd letter, so that's 22. We have a space here, so I'm going to put a 0. A again is the 1. L is the 12th letter, and G, A, B, C, D, E, F, G, is the 7th letter in our alphabet. So here's our numbers, and we're going to put these into a matrix. Now this matrix that we're going to put them into is eventually going to be multiplied to our encoder matrix. And since our encoder matrix is a 2 by 2, we need to have 2 columns in the matrix that we choose so that we are able to do the matrix operation, because remember the inner numbers have to be the same. So I know that I'm going to be using 2 columns for my matrix, so I'm going to go ahead and draw this. I don't know how long it's going to be in terms of how long these columns are, but I do know that it's going to be 2 columns. And I'm just going to start putting the numbers into my matrix in order. So a 1 and then a 4, and then the 22, and then the 0, and then the 1, and the 12, and then the 7. Now, obviously, our matrix is not yet complete because there's something missing here, but since we are at the end of our message, what should we put here? We can just put a random space. So I'll put a 0 there, just to fill out the rest of our matrix. Now I'm able to multiply that set of numbers, which is our message that we want to encode, times our encoder matrix, which was 4, -5, 2, and 0. Again, this is a 4 by 2, and I can multiply that to my 2 by 2. It needed to have 2 columns so that I could do that. Okay, so let's do our actual multiplication. I know that a 4 by 2 times a 2 by 2 is going to result in another 4 by 2. So I'm going to go ahead and put that here. I like to put little spaces here to put my math. This is my middle step. This is a review of multiplying matrices. And then ultimately I will have my finished answer. So I'll put that here. So let's multiply. Remember, we multiply rows by columns. So I like to circle as a visual the first row of the first matrix and the first column of the second matrix so I can begin my multiplication. This row times this column, we've got 1 times 4, which is 4, and 4 times 2, which is 8. I add those together and I've got 12. I stick with this same row, but I move to the second column. The first element 1 times -5 is -5. The second element 4 times the second element 0, 4 times 0 is 0. I add those up and I've got -5. And I'm finished with my first row. Now I'll go to my second row. If you like to circle it, go ahead. I'm not going to. 22 times 4 is 88. And the next element, 0 times 2, is 0. So that, of course, adds up to 88. Sticking with the second row, 22 times -5 is -110. And 0 times 0 is 0. Add those together, we're at -110. Now I'm to my third row. My first element, 1 times 4 is 4. And move across to 12 times 2 and down to 2. 12 times 2 is 24. Add those up and we've got 28. Sticking with the third row, the first element 1 times -5 is -5. And the second element 12 times the second element 0 is 0. So that's -5. And finally, our last row, the 7 and 0 will multiply to the 4 and the 2. So 7 times 4 is 28. 0 times 2 is 0. It's 28. And then finally, 7 times -5 is -35. And 0 times 0 is 0. Add that up, and we've got -35. So what we did was we took our message, assigned numbers to each of the letters, put those numbers into this matrix, and then encoded it by multiplying by the encoder matrix, which again was just some random matrix that I keep secret from everybody. Once I've done that math, this is my encrypted message. This I can send over an email or write it on a note and give it to somebody. I don't mind if anybody gets this because you cannot figure out what these numbers mean unless you have the decoder. So this is real, basically, nonsense, white noise to somebody unless they have the encoder. So let's figure out how to how to decode this message and figure out what the message is. Let's say that somebody sends you this code and we need to figure out what they're trying to tell you. Let's figure out how to do that on the next slide. Okay, so here we are on our next page and we have our encrypted message here that we're trying to decode. So we need our decoder matrix. I'm going to go back to our previous page. Here's our decoder matrix, 1/10 times 0.5 -24. 1/10 times 0.5 -24. So I'm going to put that right here, 1/10 times 0.5 -24. To decode our message, we simply need to multiply these two matrices together. For right now, I'm going to leave the scalar alone. I'll multiply that in at the end. I really don't want to create fractions in the middle of my work. So I'm going to leave the 1/10 alone for right now. So I've got the 1/10 here. I know that, again, a 4 by 2 times a 2 by 2 is going to be that 4 by 2. So I'm going to put my middle step here. And that's going to result in, I'm going to keep that 1/10 there, that, and then I'll finally have my answer right here once I put the 1/10 into that. So let's do our matrix multiplication again. I'm going to circle the first row and the first column. And here we go. We've done this a few times now. 12 times 0, negative 5 times negative 2. 12 times 5 is 60. Negative 5 times 4 is negative 20. That subtracts to 40. Next row, big numbers here. 88 times 0, well, that's not too bad, 0. Negative 110 times negative 2 is positive 220. So that's 220 right here. 88 times 5, I see 80 times 5 is 400, and 8 times 5 is 40, so that's 440. Negative 110 times 4 is negative 440. Well, that just cancels out to 0. I'm moving on to the third row. 28 times 0 is 0. Negative 5 times negative 2 is 10. 28 times 5, again, I see 20 times 5 is 100, and 80 times 5 is 40, so 140. Negative 5 times 4 is negative 20. That subtracts to 120. And then finally, our last row, 28 times 0 is 0. Negative 35 times negative 2 is positive 70, so that's a 70. And again, 28 times 5 is 140. Negative 35 times 4 is negative 140. And that cancels that again to 0. So these are the answers after the multiplication. Remember, we still have to multiply the 1/10 to each of these, which is basically knocking off a 0. So this becomes a 1, a 4, a 22, a 0, a 1, a 12, 7, and a 0. This is our encoded numbers, excuse me, our decoded numbers. Now we just have to assign those numbers, 1, 4, 22, 0, 1, 12, 7, and 0, and assign letters. So that's the first letter, that's the fourth letter, that's the 22nd letter. 0 means that there's a space. We're down to the first letter again. The 12th letter is L, the 7th letter is G, and then there's another space. But that's kind of a nonsense space. We've figured out what the secret message is. It's advanced algebra. I hope you had fun with this. Bye-bye.